Hey there, I'm Mark. Welcome to my build desk, where today the plan is to build a functional part in Blender for 3D printing. Now, normally when I've done Blender videos in the past, I'm doing some sort of artistic or decorative type of a part, usually something to add on to a model kit. But today I want to build something that's functional, that has to be precisely dimensioned so that we can fit it in the correct space. More precisely so that this Stream Deck here can fit right into it and not fall out. And normally this would be the kind of thing that people would say open up a CAD program and use a real CAD program for designing a part like this. But I wanted to show you that in Blender you can design these kinds of parts as well, and it's not too hard, and should be a fairly simple process as long as we keep our design simple. And so what I'm going to show you on the paper here first is my idea for the design. Then we'll jump over into Blender and actually build the object that we're going to print today. And that object is going to be a mount for my Stream Deck here. So you might have already noticed the layout of this video is a bit simpler than usual. I'm actually working with a fairly bare bones setup here at my build desk today because I'm in the process of sort of rearranging and redesigning my whole desk setup. And as part of that, I want to build a new mount for this Stream Deck. Normally in the past, I've just had it in this little holder that it comes with, so it just sits in here like this, and it sits on my desk. Usually it sits out of camera, so that when I'm streaming or recording video, you don't see it, but it's usually kind of up here in this corner. And every once in a while, you might notice my arm reaching up that way. That's because I'm pressing a button to change a camera angle or zoom a camera or something like that. And that's one of the things I don't like about it being here on my desk, is that I feel like I'm reaching across my project a lot to be able to hit buttons on this thing. And I'm afraid I'm gonna maybe touch a part that's got wet paint on it, or I'm gonna push some parts out of the way that are piled here on my desk if I'm having to reach across. And so what I'd like to do instead is mount this thing underneath the front edge of my desk down here to my right-hand side, so that I can just off camera very subtly reach down and hit buttons as needed to make changes while I'm recording or streaming. And you won't notice those as much as you might if I'm reaching up across the screen like this. So that is the plan. I already looked online, as I usually do, to see what already was out there as far as 3D printable under desk Stream Deck mounts. And I didn't find anything that I was super happy with. And so that's why I've decided to go ahead and design my own here. And so this is the plan. We're going to try to keep this fairly simple, just so that we'll be able to model it in Blender in a fairly short sitting here in a few minutes. So the plan is just to create kind of a rectangular frame. So this will be the size of the Stream Deck here, and this will be an empty hollow hole, and then we'll build kind of a frame around the outside of it, right? So the Stream Deck will snap down into this opening. And we've got to get this dimension just precisely so that it will snap in there and be a nice tight fit. And then we'll go ahead and just build some sort of like a little thing off the top here that's got a couple holes in it for screws. So this will sit up underneath the desk, and this will hang down at an angle, right? So if we look at this whole thing from a side profile view, maybe the Stream Deck mount part is like here, and then we've got this part here that is under the edge of the desk. And I think I want this angle here to be about 45 degrees. And the Stream Deck will sit right in there. And so that's going to be the whole design. Now I could just design the part like this and print it and it would be fine. But as I was thinking about this, I thought this would be a good opportunity to try something new that I've wanted to design in Blender for a while, but I've never actually done it, and that is a print-in-place hinged type of a part. And so rather than designing the part like this with this bend in it, I think what we're going to do is design it so that both of these sections can print flat on the print bed, and there will actually be a print-in-place hinge right here where they meet. And so it'll print flat, but then once it's done printing, we can bend this part down along that hinge and get the angle we want. So since this will be a free-floating hinge, we'll have to build in some sort of little triangular stops, maybe here and here, so that these run into each other and create the angle we want, so that it's not just flopping straight down to a 90 degree. We want it to stop at 45 or somewhere around there. So that's the plan, is we'll do a little print-in-place hinge along this axis right here where this thing is going to bend, and then we'll build some sort of stoppers here to get the angle that we want. And other than that, I think that's going to be the basic design. We might add in a few things along the way. There is a USB cable that plugs into the back of this thing, and so we might want to add some cable management clips of some kind along this piece here, some sort of a little wire channel or clip or something here to hold that cable in place so that it's not just dangling down. Yeah, so that's the plan. So before we get started, I need to measure this thing, and that's why I've got my calipers here. So we'll turn these on and zero them. And I need to find where this little lip is here, these dimensions, right? So from here to here, we're getting about 79.4, 0.3, 0.2, depending on how tight I press the calipers together. So what I do usually when I'm measuring a part like this, if I'm going to print something that this needs to fit directly into, you have to add a little bit of margin here, right? Because you don't want it to fit too tightly. So I think I'm going to go 79.5, given that we're reading about 79.3 here. So I want this dimension to be 79.5. And then the longer dimension this way is just over 113. So again, we're going to round that up a bit. So we'll say 113.5 as well here. So that's good. And then there is a little beveled edge here. I don't know if the camera picks it up or not, but there is a little curve there. And so I've got this little tool. I printed this a long time ago. Actually, if I can find a link to this, I will leave it in the description of the video for you. This has been a super handy little tool for measuring the radius of bevels. And I'm thinking this one's probably 4. Here, let me get this on camera so you can see. So you line that up, and there's a little bit of a gap there on the 3, and the 5 is definitely too big. So you just fit this in here, and so you can see that this is 4 millimeters. So we can say this little curve, this bevel here is going to be about 4 millimeters. And just looking at this, is there anything else that we need to measure? I don't think we need to know like the thickness of it or anything like that, because this is just going to fit down into the frame that we're building, so the depth of it doesn't really matter at all. I do have the cable. This is the cable here. And you'll see like this plugs in here like this, right? And so once that plugs in, this cable comes up right about in the middle from left to right of the Stream Deck. So whatever cable management bracket we create, it should be right in the middle. And just to know, let's see if we can measure the diameter of this cable. So 3.8, so it's about 4 millimeter. So I'll just make a note here that the cable is about 4 millimeters in diameter. All right, so with that information and this very fancy drawing, that is going to be what I start with here for going ahead and modeling this thing in Blender. So I'm going to go fire up Blender. I'll meet you over there in just a second, and we'll figure out how we want to make something that looks kind of like this. See if it works out. Let's do it. All right, so here we are in Blender. I've created a new file. A couple quick notes about my Blender setup here. First of all, this is vanilla Blender, no add-ons or anything else, except that I am using the ND add-on. So if you've watched other Blender videos here on my channel, you probably know I like to use this particular add-on. It creates or allows you to do a nice non-destructive editing workflow and gives you a bunch of useful tools. So I will link to the ND add-on down in the description of this video. And the ND guys have also been recently creating YouTube videos that go over all the features that the add-on includes. So I'll link to that playlist over on their channel as well if you want to check out more about that add-on. The other thing is down in the bottom right corner of the screen will be any keyboard shortcuts that I press. So if you're curious about keyboard shortcuts as we go along, that is where to look. All right, let's get started with the frame around the outside of the Stream Deck. So I'm going to create a plane, and we'll set this thing to have the dimensions that we need for that we measured on our Stream Deck. So it's 113.5 by 79.5. That was the sizing that we decided was accurate. I'm going to hit Control A and apply the scale there, so that everything else we do will work right. Tab into here, make sure that all of the vertices are selected, and I'm going to do a vertex bevel here of 4 millimeters. Again, that's the amount we measured with that little tool a while ago. Roll this up to maybe like 16 segments. And so now we have this shape, which should be the exact size of our Stream Deck that will be fitting down into this space that we're going to create here. So to create that space, let's go and in the extrusion menu here for ND, we'll do a profile extrude on this shape, and we need to change the axis to be the Z-axis. And so how deep do we want this frame to be? I'm going to say about 8 millimeters, about exactly 8 millimeters, because I can type the value in that I want. And I'm going to change the weighting here to be positive, right, so that it's sticking up above the 0 Z-axis plane. And so we'll lock that in, and now we have this is the outline of the inside of our frame. So the Stream Deck should fit perfectly within that space as long as we've done our measurements correctly. And so now we will solidify this frame, and I want to make it, I'll stick with 8 as my measurement, so 8 millimeters thick as well. Change the weighting so that it's outward from that outline that we just created, so just like that. And there we have our frame. So that's the biggest part of our piece here, and our Stream Deck should fit right in this space here. So up at the top of the frame here, we'll create the hinge that we need, and then the plate up here that will mount up underneath our desk. So I'm gonna hide this frame for a minute, and we'll zoom in here toward the middle of our origin here and work on the shape that we want for that hinge. So I think what I'm gonna do there is I'm gonna start with a circle. I want the radius here to be 4 millimeters so that it's an 8 millimeter diameter. And we'll roll this up to maybe like 32 segments. That looks good. All right, now I'm gonna deviate a bit from the non-destructive workflow that ND provides, because if I tab into this circle that I just created, there are no vertices to mess with around here. There's just the one in the middle. And I do want to make some changes, some destructive changes to this geometry. So I'm going to go ahead and apply the modifiers here, which now will give me access to those vertices. And what I'm going to do is I'm going to select like all of these, the bottom half of the circle, and delete them. And then if I pick these two, what I want to do is extrude those in the Y axis this way. I'm going to go 8 again. That seems to be the dimension or the size that we're using for lots of things. And then I'm going to connect those two. And then I'm going to create a face here to fill in all of that shape. So we have this kind of mailbox profile. And I'm going to then solidify this. We'll stick with 8 for our measurement and do something like that. Now I want this to rotate because I want it to be laying down on this face here that my mouse cursor's on. So I'm going to rotate that around the y-axis by 90 degrees. We've got that laying down like that now. And it is in the middle, like the 0 z-plane is in the middle of it. So I'm going to have to move this up along the z-axis by 4 millimeters to get it so that it's sitting flat along with our other part that we already created, right? So that now vertically is lined up with that. And I can just move this up and kind of mate it to the top edge here is the plan. So the way to do that quickly is just move it in the Y and get it past this edge somewhere here. And then I'm going to go up here to my snapping tools, and I'm going to set my snap to be to edges. And then I'm going to move it in the Y again, and I'm going to hold down Control and just lock it to this edge. So now it is perfectly lined up and connected there. And what I want to do is I'm going to create kind of the opposite of this. Actually, I'll show you. So what we're going to do is we're going to Shift D to duplicate this, make a second copy of it. I'm going to right click and drop it right on top of the copy. So both are sitting there on top of each other. But if I take one of these and I rotate it, which axis do I need? The X axis, yeah, like that. And I go by 180. It'll be like that, right? So these, the circular center of this lines up perfectly between those two. So if I cut a hole in one of them, and then I have a rod connected to the other one going through there, and I offset them from each other, that'll make a perfect hinge, right? So what I'm going to do for the moment, though, is hide that one. And we'll just work with this piece for now. And I'm going to want to copy this across here several times so that I can have alternating ones of these facing the opposite directions from each other, alternating all across this top edge. So I think what I want to do is I want to move this along the x-axis by some amount. Let's say 32. I'm going to go in the negative direction. No, I'm going to go with 40. I'm going with multiples of 8 here because I know that they're 8 millimeters wide and I want them to alternate. Yeah, that actually looks pretty good. So I'm going to start that one there. And then if I use the ND array modifier, and I've got to choose the correct axis, I want that one there, and I roll up a few copies, I should be able to get this centered just right with 6 of them, right? That offset there listed for the array modifier as well, with being 2 right now, means that it's going to leave an exactly 8 millimeter space between each copy here. So it's 8 millimeters wide, then a space of 8, then another one that's 8, and then a space, and so on. And that should be perfect to match up with our opposite side here, right? So we're going to do the same thing with this one. We're going to move it on the X. And we moved that one 40, so this one's going to have to be, or was that 32? I don't know. I don't remember now. 40 negative is wrong, so 48 to get it one more notch over that way is correct. And then we'll do our array modifier again, and we'll roll this one up to, what, 7 copies, so that they fit just like that. And that is looking pretty good so far. All right, so let's hide these ones again. And for these guys here, I'm going to cut a hole right in the center of this. And so you'll see the origin of this part. If I look straight from the side, you can see the origin is right at the center of this hole that I'm going to want to cut because it's at the center of that original circle that I created when I created that first shape. So if we create new geometry in Blender, it gets created at the 3D cursor, which is right now over here at the world origin, but I can move that. So why don't I move the cursor to the selected object, and that'll drop it right on top of that spot where we want to create this hole. That'll be perfect. So at that point, now I can create a new circle. I want this circle to have a radius of 2 millimeters, right? So that the diameter is 4, so half of the total diameter of the larger circle there. And again, we'll roll the segments up to like 32. And that looks pretty good. It is rotated incorrectly, so we need to rotate it around the y-axis by 90 degrees, which now lines it up right there. And then we will solidify it. And the exact width here doesn't matter. We're just going to use it to cut a hole out of this piece. And so just as long as it's wider than this piece is, that'll be fine. Now, before we cut this hole, this is going to be a hole that our rod is going to run through. And we want to make sure that the hole is slightly bigger than the rod that's going to run through it. Otherwise, everything will fuse together when we print this in place. And so I made this thing 2 millimeters in diameter, or in radius, 4 diameter, but that's not going to be big enough. If I want the rod to be that size, I need to make the hole a little bit bigger. So I'm going to go back into the Recon Poly settings here, and I'm going to change this radius from 2 to like 2.2, so that I'll have a 0.2 millimeter gap around the outside of, between the hole and the rod here once I get this thing all finished. That should give me enough clearance for the print in place hinge to not fuse together, and it should work just fine. So we'll give that a try. I'm going to shift select this, and I'm going to difference this out and then hide this wireframe. So you'll see here we got a hole in this piece, but all the rest of them don't have the hole in them. And that's just an issue of the modifiers in our modifier stack not being in the correct order. So we've got the array here, and then the difference came after that. So if I grab this and I drag it up here and put it before the array, then you'll see all the copies get the hole as well. And that is what we wanted. Cool. So that looks good. I'm going to bring back our opposite side of our hinge, and I'm going to hide everything else for the moment. And so what we need in this one is that 2 millimeter radius, 4 millimeter diameter rod running all the way through there. So what we're going to do is, let's see, let's move our cursor out here to that spot. And then just like we did with the other one, we will create our circle. We know we want the radius to be 2 exactly with this one. We'll roll the segments up to 32 again, and we'll rotate it around the Y by 90 degrees. And that looks pretty good. Let's see, I'm going to set my snapping to faces, And I'm going to move this along the X, and I'm going to hold down Control and just lock it to that face there. And then once I've done that, I should be able to solidify this thing. If I change the weighting, I can just pull it all the way through. And I don't know what this dimension needs to be, but we'll get it kind of close. I'm going to say probably 102 seems good. If we look straight from the top, we'll see it doesn't go all the way there, but that's fine because it's inside of this piece. In fact, I'm going to move the whole thing in the X by 1, and now it's perfectly centered. All right, so that looks good. So that piece and this piece, right, will create the hinge that we need. And there should be enough clearance inside of there. I don't know that we can see that. If I make this semi-transparent and we kind of zoom in, maybe we can see that between the edge of this rod here and then this circular opening here, there's a little bit of a gap all the way around. So that should be enough for our print in place hinge to work. All right, let's turn this all back on. And let's create the plate that's going to go up here that's going to mount up under the desk. So in order to do that, what I'm thinking is I'm going to change my snapping to a vertex, and I'm going to just create a single vertex, and I'm going to move that single vertex and hold down Control and lock it to that corner right there. And then I'm going to extrude it in the X direction only, and I'm going to lock that extrusion to this corner right there. And I'm going to select them both, and I'm going to extrude them in the Y by some amount. 32? 24? 24 is too small. Let's go 32. Yeah, that looks good. All right, and then with that shape, we can solidify it by 8, fix the weighting so that it is lined up with everything else. And that is going to be our under desk mounting plate, right? Okay, next, these little spaces here are a little bit annoying. Like, they're fine, but I would like to tighten that up just a little bit. And so how am I going to do that? I have an idea. All right, let's create another single vertex, move it, and lock it right there to that point. Then I'm going to change my snapping to edge, and I'm going to move this vertex along the y-axis and lock it to that edge. Good. Now I'm going to extrude along the X, and I'm going to lock it to this edge. Yep. And then let's look straight from the side. Change this back to vertex, and I'm going to make sure I have both of those vertices selected. This would be easier if I just turned on X-ray mode there. Okay, cool. So we'll look straight from the side, there we go, and extrude those in the Y direction this way, and I'm going to try to lock them to the point, kind of the apex of this curve, right? So just like that. So now if I take that piece and I extrude or solidify it up again by 8, fix the weighting so it all lines up, then I've filled in this gap. The problem is the filling in of this gap touches that. I don't want that to be the case. I want to leave a little bit of a gap so that when I print this, it doesn't fuse together. So I'm going to take this piece and grab these two vertices and move them in the Y by 0.2. That seems to be the gap that we're using in a negative direction. And now I have a nice little gap right there. Okay, cool. The next problem, actually let's first of all copy this over to here as well. So I'm going to Shift D duplicate this and move it in the Y and lock it to that edge there. We still have a little gap there as well, so that's good. All right, speaking of gaps, we do not have any gaps between these hinge pieces, like right here where I'm pointing with my mouse and all these spots. These things are touching, and they're not going to print well. They're going to fuse together when they print. So we need to actually adjust the width of these pieces so that there's a tiny gap on either side. So the way to do that is to go back into our solidify modifier here, which we made 8 millimeters. I'm going to change them to like 7.8, which makes that piece narrower. Now you'll see the other side effect it had, because of the way the array modifier works, is it messed up the spacing of these so they're not lined up correctly anymore. But that's fine, because we can go back into our array modifier and we can change the offset parameter on this. And you see when I do that, it adjusts that. So I'm not sure if I need it to be 2.1. No, that's too much. 2.05 looks to be the correct value. All right, so 2.05 is right there. So what we're going to do is, again, same thing on these opposite pieces. We're going to go back to the solidify. We're going to change this to 7.8. And we're going to go into the array modifier and change the offset to 2.05, right? Is that what we decided? That looks good. All right, now that we've made that a little bit narrower, we have a new problem that these didn't line up. So I probably should have done that little change there with those hinges before I started working on these other parts. But it's fine, we can fix these things. So we're gonna move these in the X direction and we're gonna line them up with that. Same thing with this. Line them up with that. And these two. So these little adjustments I would not have had to make had I done this in a different order. But, you know, that's part of this type of modeling. Like I haven't done a lot of planning ahead, right? I've just decided to kind of freeform it. Come on, lock, there we go. And so I'm fine with having to make little adjustments like this as we go. All right, so that is looking pretty good. And I'm happy with all the gaps that we have there. So like if I look straight down from above, you'll see here if I zoom in, you can see all the nice little gaps here. And these are all 0.2 millimeters or 0.4 millimeters. Yeah, because it's 0.2 on either side. So that will, that'll be fine for printing. That should leave us enough gap for this hinge to work and for things to not fuse together when it prints. So what do we want to do next? We're going to have to put a couple of screw holes up there. And so to do that, let's move our cursor back to the world origin so that we can work on a cutout for a screw piece down here where it's out of the way of everything else. And we'll start with a circle again. I think I want this also to have a 2 millimeter radius. And we'll roll the segments up. Maybe 16 is enough for this. That'll be fine. And we will solidify this. I'm going to go 6 millimeters, I think. So the full thickness is 8 millimeters, but I also want to have a tapered head space up here at the top for my screw. And so I'm going to actually just go ahead and apply this geometry. Yeah, let's do that. And yeah, that'll be fine. I'll apply that geometry and then tab into here. And what we'll do is we'll grab this top circle here and we will extrude it along the Z by an additional 2 millimeters. So that gives us our full 8 millimeter height. And then that top one we're going to scale by probably a factor of 2, maybe. I didn't do that correctly. Extrude and then apply that change and then scale by a factor of 2. All right, so if we do that, we have a shape kind of like that. I'm also going to take this and extrude it again by another 1, just to give it some overlap so that when we cut things out, it'll be good. I'm also going to grab this bottom here and extrude it by 1 as well. Okay. So that will be our shape for our screw hole cutout. Now, if I look from the top, I want to move this up into position up here. I think I just want to have 2 screws, so one here, one here. That's what I'm thinking, yeah. So we'll snap this to like edge centers, and we'll move it on the y-axis, and we'll snap it to this edge center. Now weirdly, that snaps like the top edge of it, not the whatever, so I'm gonna actually then move it on the y by an additional 4. Yeah, which gets it centered there. All right, so it's centered vertically here. To do the horizontal, I don't really care too much that it's perfect. I'm just gonna kind of eyeball this, so I want it centered between this and this center axis here. So somewhere around there should be fine. Yeah. Then I'm gonna set its origin to be the 3D cursor, which makes the origin of that shape be all the way down here. But the reason for that is then I can just mirror it. And if I hit flipped there, then it mirrors across wherever it thinks its origin is, and so we get another one over there. So that's perfect. Then I can select that, I can shift select this, and I can difference it out. And it didn't like that, and so the other thing you can do is say swap solver with ND. And that usually, it swaps between the fast and the exact solver for the modifier, and that usually fixes a problem if you do a difference and it doesn't work. So there we have our 2 cutouts for our screws. That looks good. And I think the only thing left is the stoppers that are gonna stop this thing rotating too far. So how do I want to do that? I have an idea here. Yeah, here's the idea. Let's start over here. And let's create a little triangular shape. So I'm going to snap to vertices again. I'm going to start with a single vertex, and I'm going to start it right here on this corner. Yeah, that seems good. All right, if I extrude this over here on the x-axis to this corner, that seems good. And then I'm going to extrude both of those in the y by, let's say 8, because that's our dimension in the negative direction, right? So it'll go that way. And then I'm going to pick both of these as well and extrude them in the z by 8. Yeah, this seems good. And then I'm going to connect those up with a face and just fill in these 2 triangular sides as well. So let's talk about this for a minute. If I have this triangular piece sitting here, when this hinge turns, when this piece here folds up, it'll stop at a 90-degree spot, right? Because it can turn all the way up till it hits that. So that'll make us a 90-degree angle. What we actually want is, of course, a 45-degree angle. So if I duplicate this and then move it only in the Y, and I snap it to right there, now when this rotates up, this face here will hit this face there, right? And it will cause this thing to sit at a 45-degree angle, I think, if I've done that correctly. Yeah, that seems good. Now, this is going to probably overlap over the top edge of this a little bit, right? So we don't need this entire point here. We could actually cut it off like right here, and that would work okay as well. Or why don't we do this instead? Yeah, I would like these tilted the other way, I think. So what I'm going to do is I'm going to grab this and move it on the Y and lock it that way. And I'm going to grab this and move it on the Y and lock it that way. I think I like this better. This way this will rotate down and hit that. and it'll hit it only like halfway up that as well. So I could actually go to this guy and I could say move in the Z by 2 negative. Is that 2 or 4? Actually 4 is correct here, right? Yeah. So we'll move it in the Z by 4 negative. 4, no. Move it in the Z by 4 negative. There we go. I don't know why that was so hard. And then if we snap this to edge center, we can move it in the Y and center it along there to make that 45-degree angle. All right, that was confusing for me to explain and probably confusing for you to understand on the video here. But the idea is now that as we rotate this piece up, this will come down and will perfectly meet with that and should cause this to sit at a 45-degree angle. That is my thinking there. And so now that we have that, we can go ahead and use our array modifier, picking the correct axis, which is the correct axis. It's that one. Nope. Not that one either. There we go. And we can put that out along there. And we can see that the spacing isn't quite right because we have to change the offset to 2.05 to 0.05, just like we did with the other things, and then that should line up perfectly. Yeah, that looks good. And then we'll do the same thing there with this one. So that many, and we'll say 2.05. And that looks good. But I said I wanted to create some sort of a cable management solution for the middle here. And so I don't think I want these stops in the middle. I think I'd like 3 and then a gap and then 3. So to do that, what I'm going to do is I'm going to go to here and I'm going to just do the 3. Same with this one. We'll go back to our array modifier and roll that down so it's just 3. And then because on these objects their origin is the center of the world over here, yeah, I should just be able to say mirror like so. Nice. And then I've got the 3 on either side that I wanted with a gap in the middle. So let's make a little channel here, I think, that I'm just going to press fit the cable down into. And we know that that cable was, what, 4 millimeters in diameter. And so we will go ahead and come back here to our world origin and create a circle that is 2 millimeter radius because it needed to be a 4 millimeter diameter. And we will give it 16 segments. Seems fine. And then I'm going to have to create some kind of a profile that's similar to that mailbox type shape that we created before, I think. Yeah, let's do that. So we'll go ahead and apply this modifier and tab into here and grab the bottom half of these points and delete them and grab these and extrude them in the Y by 2, like that. Yeah, that seems fine. You know, I think, yeah, so here's the idea. Let's grab these 2 again, extrude them. That was not what I wanted to do. Undo that. Extrude them in the Y by another, is 1 too much? Yeah, 1's probably too much. 0.5, cool. And then we'll move this one in the X by 0.5, and we'll move this one in the X by 0.5 negative. So what I'm doing is I'm creating this little kind of overhang that's going to, I think, help to lock the cable in place. Hopefully this will all make sense when I move this into place for you here. So I'm going to rotate this around the x-axis by 90 to stand it up, except it's upside down. So I'm going to rotate it again by 180. There we go. All right, so what I want to do is I want to move this in the Z up to the level of everything else here. And then I'm going to move it in the Y this way, right? And then I'm going to move it again in the Y and lock it to this face. And then I'm going to extrude it. Not extrude it. I'm going to solidify it like so. Only in that direction. I'm going to go, I don't know, to about there. What is that? 29? Let's go 30, 32 would be the full width of that thing. Let's go 28. Yeah, that seems good. And then I'm going to move it in the Y by 0.1 just so it's hanging over the edge here just a touch. And I'm also likewise going to move it in the Z by 0.1 so it's sticking out the top just a touch. And then I'm going to shift select that and I'm going to difference it out. So all of that work to create this little channel, which is the correct width for our cable, with this tiny little overhang at the top here that should allow us to kind of press that into place, and it will stay nicely snug in there once we're done. That's the idea, at least. And with that, I think I'm happy with this part. Yeah, seems good. Now we're going to export this, and some people have asked me, like, how do you export, because this is a bunch of different objects here in Blender, right? You can see over here in our tree, we've got, 8 or so different objects. Do you have to union them together or that sort of thing is the question that I get a lot when you're exporting this as an STL. And the answer is no, you don't. So if we go over here to File, Export, and we try to export as an STL, you'll see that one of the things that comes up is this. We've got some controls over here when we try to export. So selection only is a checkbox that I almost always have selected when I export, and then apply modifiers. So if we say apply modifiers, it will apply all of the things that we did in ND. And then if you have multiple objects that you're exporting, it will automatically fuse them together into a single STL when it does the export as well. And so the reason that we want to do selection only, though, is we've got these hidden utility objects over here that were our cutouts for like our screw holes and stuff like that. You don't want to be exporting those objects because that will plug those holes. And so what we want to do is we want to hit A to select everything that's visible here. And then we do our file export as an STL, and we make sure that selection only is checked and that apply modifiers is checked. And now we will get a single object that is everything we have selected here. So then you just give it a name and you hit export. I'm not going to do that here on the video, but I will do that in just a minute. And then we will load this thing up over in my slicer and get it prepared for sending to the printer. Okay, so here we are in my slicer. Right at the moment, Orca Slicer is my slicer of choosing for most of my 3D printing projects. It's really great. I recommend it. If you haven't ever used Orca Slicer, give it a shot. It's got a lot of really good features. Anyway, we're going to keep this simple today. I've got my profile loaded up from my Voron printer. I'm going to be printing this thing in black ABS, and so I've got that set as well. And I'm just going to grab the file that we exported from Blender and drag it into here. So there is our Stream Deck mount. And it's obviously oriented correctly because we designed it that way in Blender when we designed it. We designed it to lay flat like that. And so I don't think that there's any settings I need to change or anything like that. I'm just going to hit Slice Plate. And we're going to go in here and double check just to make sure that this thing looks like it's going to print correctly, especially in this hinge section, right? Because we care about the clearances in there. So I'm going to pull this down a bit. We'll go all the way down to the very bottom layers and take a look here just to make sure like we have enough gap here. We have like one extrusion width gap between these parts of the hinge down there, which should be enough. Yeah. And then as we go up, we're still good here. All right, so here's the base of right here. This red part is what I'm looking at. So that's the flat part of the bottom of this piece of the hinge. Then we've got a one layer gap, and then I went too far. This one right here is our first bridge layer for the peg that's going to be in between. So there is, again, a 1 layer gap before we put that peg in place. These look like they have a decent gap around there. And then we go up to the top here. There's the top of our pin right there. We've got 1 extra layer, and then we're bridging across the top for that. And so again, we have a 1 layer gap, and then we fill it up. Okay, so I am happy with that. I think it's gonna print okay. And it's gonna print in about 1.5 hours. So I'm gonna go ahead and send that over to the printer, let that thing print, and then we'll come back and take a look at it when it's done printing and see if everything fits and hinges correctly and sits at the right angle and all of those details. We'll see if that came out correct. All right, here we are, moment of truth. I've just taken this part off of the printer. So here we are. This was the bed side, of course, and then this was the part that was facing up. And we've got our hinge here, and with any luck, I should be able to, it's a little bit tight, but yeah, I can get this moving and just kind of flex it a bit to loosen it up. Yeah, that looks really good. Okay, so this is our angle. This is where our stops cause our angle to stop. So that's just about what I had in mind. Excellent. The rest of it's nice and solid. It seems like it's, yeah, I'm not concerned at all about this like falling apart or causing the Stream Deck to fall off of my desk. So that's good. Here are 2 screw holes for mounting up underneath the desk, and those are looking good. We'll try out this cable channel here in just a minute for the USB cable. But first of all, let's see if this thing fits in here. So, yeah, it popped in there quite nicely. It's a good snug fit. Yeah, in fact, I can shake this and it's not coming out at all. So that's really excellent. And it looks good from the front too here with the textured frame around the outside. Yeah, that's gonna look nice. Awesome. All right, and I said we'd try the cable, so let's do that as well. I've got the cable right over here. So I'm not gonna plug it in right now, we'll just try. So it'll be plugged in like so, and then we should be able to just kind of press this down into this channel. That was the idea. Yeah, that works actually quite well as well. It's not coming loose. So that sizing was good. And that'll keep the cable from hanging down below the desk and hitting me in the knees and that sort of thing. So that'll be nice too. Awesome. All right, so all that's left is for me to figure out where along the front edge of my desk I want this to be placed, and then grab 2 screws and go ahead and screw this up under the desk. I won't show that here in the video because that's kind of not the point, right? The point was this cool 3D printed part, which turned out really nice. So yeah, let me know down in the comments if you've used Blender to build any type of, you know, like 3D printable functional part like this. Usually I use Blender for more decorative and artistic types of parts, you know, things to add on to model kits and that sort of stuff. Not big functional parts like this, but it worked quite well in this case. And yeah, I'm happy with how easy it was to do and how it turned out. So if you've got experience with this and have ideas about, you know, what works and what doesn't as far as modeling functional 3D parts in Blender, let me know down in the comments. And other than that, I will get this installed, and hopefully in the next video we'll have a much more, the regular setup will be back with maybe even a few extra bells and whistles as well here in the studio at the build desk. So I hope to see you for that one, and until then, go design something awesome. I'll see you next time.